All right. Here comes an update on the negative externality story. Actually, I started recording something, but I figured I can go a little bit faster without maybe writing down as much. So I'll just talk and then draw some graphs and write down some formulas instead of writing stuff down, and as I was trying to do here. So negative externality. It's a situation when there is like external cost generated by a particular activity. And external cost is cost on someone who is not involved into this activity. So when thinking about an example of negative externality, you should always like separate like a goal by whoever is doing something, and then marginal external cost that affects someone else. Okay, examples: industrial pollution, like people going to work when they're sick, right? So you balance your private benefit and your private cost, but if they're like external cause, then that's the case of negative externality. So if you're sick and but you figured out you can make it to the work, you're probably not thinking too much about the effect your being sick has on people around you. And of course, like in these situations, you have to be careful, making sure that whoever is doing something, right, not really taking this external effect into account. Because I mean, if you understand the consequences of your actions in terms of how it's going to affect others, and also care about these consequences, then it won't be an externality. If you know that going to work will make other people sick and staying home because of this, on top of other things, right? Then it's not an externality. You're actually doing the right thing, and you're doing a rational thing, not just for yourself, but basically for people around you. And then it's not an externality. If you're going to work without thinking about other people, then it's an externality. All right. Now let's talk about, I guess, graphical analysis of this story. I'm kind of slowing down because I'm not sure if maybe I should give you more examples, but I think what I told you already hopefully makes sense. So think about it, apply this logic, think about your own examples. And now, graphical analysis, like theoretical analysis of this stuff. Well, let's recall the story of efficiency we covered earlier. So we talked about marginal cost and marginal benefit of particular activity, right? We figured out that if it was the only benefit and the only cost, then the point of allocative efficiency would be here. This is where MB equals MC, and that would be the point of allocative efficiency. We also talked about like inefficiency being measured by deadweight loss. So for example, if you overproduce at Q1, then you actually generating this deadweight loss. Speaking of efficiency, remember a big part of efficiency was total surplus, which is this area. And one way to understand efficiency is to realize that at the point of allocative efficiency, you're getting the largest possible surplus from this activity. So being exactly here, producing up to this point, producing and consuming gives you the largest total surplus, and producing less or more will actually reduce this surplus. And it's actually an overview of what we did in the previous class, right? So that will be deadweight loss if you produce too little, and clearly because if you stop here, it means you only grab that surplus and you will fail to grab this surplus. If you produce at this level, then in fact you will keep this surplus, but you will also add this negative surplus, right? Because beyond this point, MC exceeds MB, and this area becomes not a good thing, but a bad thing. So that was the story of deadweight loss in case we only had private cost and private benefit. Now we're going to introduce marginal external cost into this story. And in fact, from marginal external cost in combination with private cost, we're gonna get marginal social cost. So we need to take these two things, marginal cost and this thing which is already on this graph, but we also need to take this marginal external cost into account. And let me draw a separate diagram for that so you don't get confused. You get marginal private cost, marginal private benefit. This point, I'm not marking it as the point of allocative efficiency because it's not going to be the point of allocative efficiency anymore. Now, how are we going to show marginal external cost here? Well, we're going to draw a line, just like a line with lines we drew for other variables, right? For MC and MB. And if we do it, we can do it like this. That probably will be the best way to do it. This is marginal external cost. Okay. And then how do we go from this to this one? You see, like mathematically, they're just, the sum of each other. Graphically, it's done by pretty much picking a couple of outputs, like let's say Q1 and Q2, right? And then pretty much like measuring MEC at Q1, then grabbing this distance, and then putting it on top MC, and when they put on top of each other, you actually get a point on your marginal social cost curve. And you do it at least twice. So see what I'm doing? Taking this distance, grabbing it, putting it on top of MC. So together they give us marginal social cost at this level of output. Now you're connecting these two dots, and well, let me redo it. Sort of, kind of, okay, I think it's good enough. Well, maybe not. Let's do this. Okay, better. And then extend it here, extend it here. Well, the most important part is around where MSC, right, this guy, intersects our MB. So as you came up with your MSC curve, you pretty much should forget about your MC. MC only matters for figuring out the market equilibrium. If we're talking actually about supply and demand, then this is where the market will be if you leave it alone and let it do what it wants to do. And the markets basically want to be at an equilibrium, right? Where supply intersects demand, or where quantity supplied matches quantity demanded. But again, this point is not the point of allocative efficiency anymore, because MC in this case underestimates the true cost to the society. So we actually want to use MSC to figure out the point of allocative efficiency. And we're going to do that by relating it to MB, which still matters. It's still valid, right? We didn't adjust MB in any way. So we're going to use it. And we're just going to find the point of allocative efficiency where these two curves meet, or two lines, right? Oops. So this is the point of allocative efficiency now, when marginal external cost has been taken into account. And when we came up with marginal social cost that takes care of both costs, external and private, and using it, we can now find the point of allocative efficiency. So now let's see how we find deadweight loss. And the logic is very similar to this story, except that instead of using MC and MB as we did here, we're going to use MSC and MB. Okay, but the rest is very similar. This is the point of allocative efficiency, just right here. And then deadweight loss, it depends on how far away we are from this point of allocative efficiency. You see, here we got deadweight loss based on us being away from this point here, and here deadweight loss is based, again, how far we from this point. And well, we know the market will be here, so that will be dead weight loss. Let's shade this area, dead weight loss. All right, I hope you can see the similarity, and I hope you will be able to separate these graphs, remembering that on this graph what we use is MC and MB to find the point of allocative efficiency, while here we're using MSC and MB to find the point of allocative efficiency. So yeah, this graph clearly not the same, but the logic is very similar. All right, so that is pretty much it. One more thing, on this graph I'm showing you what happens when marginal external cost is an upward sloping curve, which means marginal external cost actually changes as we increasing the output. You see, the more you produce, the more, harm each unit adds, every time you increase your output. Another simplified case could be this. If I actually gave you a simplified version of marginal external cost, which would be a fixed number for it. So let's say it's $100. How would it look on the graph? Well, if it's the same number for any quantity, it means you will have a straight horizontal line. So it will be like $100 everywhere, whether you're producing a lot or a little, it always adds like 100 to your external costs as you adding one extra unit. And so this story actually will get even simpler. So instead of like measuring these different distances or heights, right, and putting them on top of MC, you pretty much can take this number and put it on top of your MC at every point, which basically gives like a parallel shift in your MSC curve. So if you ever encounter this kind of situation, just don't worry, it's actually easier and simpler than this story. All right, I think that summarizes this exciting story, and I will stop here.